Hello everyone, my name is Shindavasti and today's topic of presentation is dynamic KML generation with Node.js and APIs. So in this topic we are going to look up at how we can send data from external APIs to the Liquid Galaxy rig using not using the Flutter app as the main controller. We are using Node.js as a middleware. So for KML generation we are using Node.js and it would be sent through an app, so it will help in data visualization and in this video I will demonstrate the working app and give full code explanations. So moving on to the first top which is introduction to Liquid Galaxy. So Liquid Galaxy is an immersive panoramic viewing system which allows users to fly through Google Earth using multiple synchronized screens. So it will offer a 360 surround experience that one can control using only one systems. So it provides a navigation from all screens using only a single screen. It is an open source project which is also collaborative and used for data visualization, education, and exhibitions. The master slave architecture. The Liquid Galaxy follows the master slave architecture. It has one master node which acts as a central computer which controls the all the slaves. So it acts like a brain of the algeric, and it sends the broadcast package commands to the slaves, which are displayed through the Google Earth. Then all other machines are getting connected to the master node. It acts as a single point of control and distributed workflow with real-time updates. Then how our mobile app and algeric got connected? So we it get connected to the Dart SSH2 library using Flutter, and it uses the SSH client for connection. It uses secure shell, and since Liquid Galaxy requires strictly KML files only, so and the APIs give modern APIs give data in JSON formats. So we have to convert the JSON format into KML, which could not be done into Flutter since it requires battery and more storage. So now we are using Node.js as a middleware. So the Node.js server we have created acts as a translator to convert JSON files into KML files, which get displayed on the algeric using the server commands of command commands. Then if external API changes, we don't have to redeploy the app or reinstall the app. Just we have to change the external API and whole work is done. We don't have to touch any other thing in this. So it is also scalable and more efficient. Moving on to functionality of this app, which I am going to show. So we are connecting the external API to the static KML based Google Earth. So what external API we are using? We are using International Space Station API, which is open source. So it gives the endpoint of the latitude, longitude, and marker to show the exact location of the International Space Station, and we are showing it on Google Earth through converting to KML using Node.js. First of all, the user presses button in an app to send KML. The Flutter sends the request and credentials to the node server using OKHTTP request. Then the node calls external API, which is ISS, and it constrains a KML of a string with the coordinates which it has fetched through the API. Then node secure shells into algeric, sends KML and fly2 commands to display the international space station, and the data is displayed on the algeric. So before moving on to code explanation, let's see the working of the app. So here is the working demonstration of the app. So we have the working synced algeric. Then we have this home screen which gives send KML button which flies to ISS via Liquid Galaxy, and we have clean KML button. In connection tab, we have node server IP, LG master IP, username, password, port, and rig, and a connect button. Node server IP is the IP which gets connected to the node server in which the server is running. So for now, I am using localhost for running the servers. Since it is in this laptop only, so we are using command prompt and writing a command ipconfig. So we will get to know about the IP address of the connected Wi-Fi. So it is wireless LAN adapter Wi-Fi, and we have IP4 address as 172.22.75 and 199. We will enter this address here, and the LG masters IP, which is the LG rig LG1 IP and username, password, port, and rig. Then we will click on connect. So it will get connected to the uh, node server through the Flutter app. Then we have this then we have to turn on this server using node index .js command. So clicking on it, we will get result as node server running on port 3000. So moving on to connect. After connecting, it will show a toast message connected to LG rig, and when we press on send KML, the request gets transferred to the node server, and it will start gets processing, and the camera will fly to the required space station. And as you can see, a place marker of pin, which is by default in Google Earth, it gets pointed to the ISS coordinates. And as you can see here in also of server terminal, it is fetching data from API, then data receives, which is latitude coordinate and longitude coordinate, and sending KML and flying to LG. Moving on to clean LG, it will remove the place marker from the LG rig, also using the server commands. I will show it later. This is the whole demo of the app. Let's begin with the code explanation of the app. So the basic file structure of the app is connection screen, home screen, Liquid Galaxy service, which holds the all services, all the functions of the app, and then main.dat. So moving on to next page, which is dependencies in the project. So I have used HTTP request for sending the request to the node server using OKHTTP3 client. Then we have shared preferences for storing the connection details. Then we have Dart SSH2 dependency, which is used for establishing connection between the app and the LG rig. And each of these dependencies is purpose driven and directly supports secure, fast, and friendly user friendly communication with Liquid Galaxy rig. Moving on to LG service.dart file. So first of all, I have import async function. Then we have convert, and then we have Dart SSH2 to connect to the node server. Then we have HTTP package. Then we have shared preference package. So first of all, going on to class constructor. So we have created an instance of the LG service. Then we have created also a factory and an SSH client, which is used to connect to the node server. Then we have node server IP, LG user pass, and port, and the rigs, which is all other fields from the connection screen. Then we have created a boolean variable which shows if it is get connected, it will show perform different tasks or will proceed, and if it is not connected, it will return null and shows us the toast messages and the warning. So moving on to the first function, which is load settings. It will load the settings from shared preferences, which is firstly stored, and its basic values are written like this, which in the user and password we have LG. In the port we have basic default port 22, and minimum screens or the rigs is 3, and the default IP structure address is 192.168.xx. So from this function, we are using the shared preferences to load and get instance of the previous settings we are entered into connection model. Then save settings function also overrides the previous settings and helps us to uh, create the instance of the shared preferences and then edit it. Then we have another function, connect to LG function, which is another more important function of the LG rig, which connects the LG rig to the node server using the SSH client. This is a main function. So we have created a socket which connects the LG service using IP port, and also it has given a timeout duration, so to avoid the lag free experience. Then we have SSH client, which receives 3 functions, which is socket, username, and our password request. So it will get password, username, and its socket. Then we have using the string from char codes to provide the connected output result. And if the connection is successful, we are debug printing SSH connection successful, and if not, we are debug printing the error. And in this kind of function, we are closing the SSH client and setting its value to null. Then our other function, which is send KML to node, which uh, uh, which sends the our details of connection model to the Node.js server for the secure connection between the node and the Algeric. So it uses HTTP 3 service, and first of all I have created the node server IP, which if not equals to null, tries the block, and if it is null it returns false only. So it will error case. Then we are in try case, we are using a response as HTTP request, since it is an API, so we are working on the response. And if the node server API of the 3000 port is available, we are using the fly to ISS function, and it will get called and get posted to the node server. And its body include host, username, password, and port. So it will get connected to the SSH. We will see later on. Then if the response return is 200, which is successful, so we will get out of this block. And if it is not successful, we will print error calling node server. Then we have also a function of clean LG, which uh, cleans the which sends the command of cleaning the rig. So same functionality it is used as sending KML to node, since it is posting the HTTP request to the node server, and through user password and SSH port, which does not require reconnection. But since we are sending it, so we have to send the JSON in a clean format. So moving on to the main brain of the app, which is the Node.js server. So first of all, we are using the Express package, then Axios, then SSH2, then cores, and we have created an instance of the Express class. So discussing on everything. So Express is the package using for API call. Then Axios is also doing the same thing. Then SSH2 is connecting to the Algeric to the server. Then we have cores, which used to send the data from server to the app. Then we have creating the instance class, and we are using express.json here, and also using the cores. So moving on to execute remote command function, which first of all establish the SSH connection with the app. So first of all, we create a new promise, which accepts two command, resolves and reject. And if the new client is available with the ready function, we will execute the command, and if it is not, we will get the error. So on creating the error, it will close the code signal and end the con. And on receiving the data, which is the username, IP, pass, and host, it will std out the means print out the data in the terminal. And if it is error, it will also print the error. So here is the connect function, which is the connection model, which we are seeing here: host, port, username, and password. Moving on to next function, which is main KML sending function. So after connecting to the SSH, we are going to send the our JSON body to the KML body. So here we are receiving the request in the JSON format, then we are sending the response, so in a asynchronous manner. So it will not give more load to the node server also. Then since request body is host, port, username, and password, if it is null, so we'll simply return the 400 JSON code, which says error message. And if it is not, then we will send the message of fetching data from API, and then after calling it, the API from Axios using await function. This is the API which is freely available, and its endpoint sent us the coordinates of the latitude, longitude, and the position of the ISS data, storing it in an array of latitude and longitude, and setting the altitude to 40,000, 4 lakh, which means the Google Earth will show a wide view. And then after successfully executing this, we will print out the data received in the form of latitude and longitudes. Then moving on to the KML construction part, we are using the basic KML structure of OpenGIS and the Google Earth. Then its name is ISS Live Position, and the KML name is International Space Station. We are using cdata function here to display the latitude and longitude. And Also we are using the uh, relative view, so we are using the extrude one command here. Then we are also using the place mark as a pinpoint, so it is displayed here. Then we have a fly to command, which flies to the camera to that longitude and longitude, which the API has provided here using GSoC. Then in the terminal we will display a result set as sending KML and fly to LG. Then we have function of execute remote command, which I have discussed earlier, which sends the or echoes the KML content to the network link, which is discussed here, which is where www.html, ISS-KML, and also the fly command, which is temporary query. Then we will store the response in the JSON, and store is at success, and a message in the data. Moving on to the blank KML, which is used to which is used to send for the cleaning the LG. So in this blank KML, we are sending the clean KML, which stores nothing, so the LG rig will get cleaned. Then its function look like this, like we have host, port, username, password, and request.body. And on pressing the clean button, this function gets triggered, and it will shows cleaning LG. And same execute remote command and blank KML is getting sent, like where www.html kml iss.kml, and it is echoing the blank query. Then in response we are using the status as success message and message as LG cleaned. In case of error, this will return the error response code of 500. And at last we are listening to app.listen 3000 and 0.0.0.0 port for connecting to the LG server, because if we do not provide this IP address, it will get connected to its own system, and it will on starting the server, it will give node server running on port 3000. So moving on to the code of connection screen dot, we are creating the class of connection screen using the stateful widgets, which detects the changes. And we have initialized the form controller, which has text editing controller, which uses node IP, LG IP, user, pass, port, and rigs. And we also have a boolean variable of is loading, which is initially initialized to false. And then we have init state, which loads the preferences. And in the load preferences function, we have the uh, function of LG service, which is displayed as load settings, which loads the details of the connection screen using the model. Then in the connect function of the connection screen, we are using the current state validation as true, and it saves the credentials to the shared preferences using the LG service also. And if it's success, it gets connected to LG using the LG service function, and displays the snack bar message connected to LG rig, and else it displays SSH feed. Moving on to the widgets, we are using the normal widgets like rounded rectangle border, and displaying the text as liquid galaxy connection. Then we have used the build the text fields in separate widgets, and its children's controls the all text fields also. Then we have a loader here, and on pressed we are using the connect function, which calls the LG service dot connect. Then we have build text field widgets, which use controller and obscure test for entering the details, and its validator is converted to the required if it is its value is null. Then we have home screen dot, which look like this as we have shown earlier, and it is also a stateless widget, since it does not require any changes. It is pressing only buttons, so all the work can be done in at the backend. So it displays the title as LG controller, and we have some gradient displays that here, which of two colors. Then we have center widget, which displays do the two action cards, send KML and clean LG. So send KML card pressing first checks if LG service is connected. If it is connected, it shows the uh, snack bar of node server processing, and calls the lg service dot send KML to node function, which sends the HTTP request to the node server and receives the request from the call server. Then if it is not, it displays a warning of please connect to LG first. Then we have action cards, like as in before, the connection screen widgets. And we have also a clean LG button also, which on pressing uh, uses the function LG service dot clean LG. Then this is the card which uses the simple design schemes and follows the overall theme of the app. And it uh, it also requires a show snack bar widget, which so we don't have to rewrite everything. Summary of the app is we are creating a scalable and efficient app used to connect the LG rig to the node server using Flutter. Since we are not converting the JSON files onto Flutter because of excessive battery drainage and excessive resource use of the app, so keeping it efficient and lightweight, we are using a server at our local host, or we can deploy it at a Docker service and use it. So this is all for today. Thank you.